Here's my exam 2 update for the number theory course that I've been taking. And so I already have some ideas for videos that I want to do for specific problems, but I'm going to do these, I think, right before the final, so it'll be like near the end of the year, sometime in December, and I'll put them out slowly so people don't get bored when they watch these. There's not too much, I'm not going to upload like 20 of these videos. I'm going to make a whole bunch of them, but it's going to be later. But I already have the subjects. These are the ones for the second exam. And here's my assignments. Then when it comes to the course itself, there was already a number theory 5 notebook that I already finished. That was the one for the first exam. Then in the one for the second exam, it's got what I've shown already, which is all the practice for the first exam. And I'm not going to show that here because I already have shown it in a previous video. And then and of course, I think at the time, I also showed my proofs review, and then I did like a little summary of whatever happened in the exam. But then I started watching the follow-on videos for multiplicative functions. What was it? Multiplicative functions, quadratic reciprocity, and primitive roots. So here's the content for multiplicative functions. Heavy emphasis in this course. I think the professor who teaches this course is an analytic number theorist, and that's his thing. So strong focus on these, which is great. Good stuff. Of course, the number of divisors, which is new. Usually, is also tau in other books. The sigma, so the sum of the divisors of a number. More focus on the Euler phi totem function, phi, or phi, I think it's phi. Then, of course, the Mobius inversion formula with the mu's, all that good stuff. Took a bunch of notes. Then I started working on problems. Chapter 3 for the book is the one that has multiplicative functions. Just worked out a few problems and started working on problems for the homeworks. Did the homeworks. A couple of proofs. And it all went pretty well. Then when I got to quadratic reciprocity, let me see where that is. I had already done a fair amount of quadratic reciprocity when I tried to teach myself. And I say tried because there was some things that I did succeed in teaching myself and some that I didn't. So here's quadratic reciprocity. One of the big things that I got better at is doing Legendre symbols and realizing, incredibly enough, when I taught myself quadratic reciprocity, I didn't fully understand. I have no idea why. Maybe I learned it, then I forgot it, but now I know it for a fact. Was that the product in quadratic reciprocity is the whole product. And so, let me see if I find the formula. I know the formula by heart, but I want to find it in my notes. There we go. So, quadratic reciprocity, I would write it like from memory as Q over P times P over Q is equal to -1 of P minus 1 over 2 times -1 Q minus 1 over 2. It's not. You have to do the whole product of P minus 1 over 2 and Q minus 1 over 2. And so, of course, what that means is that when you're doing a Legendre symbol, if one of the two numbers is type 3 mod 4, 1 mod 4, which is a 5. 5 is a good example. So 5 minus 1 is 4, divided by 2 is 2, -1 to the 2 is 1. And so if one of these two numbers gives you an even power of -1, it doesn't matter what the other one is. You can flip the Legendre symbol. I'll show that in a little bit. But either way, also -3 over P, doing -3 over P, which I spent an ungodly amount of time when I was self-teaching. And there was an answer for it in the back of Rosen. Even after I looked at the answer, I was like, I don't know, I'm still missing something, which sucks. But now I understand it. Now I do. And so And I think I'm gonna make a video about that at some point. And the key is that the way it is usually shown, the answer that is usually shown, passes through a simplification that nobody explains, which is that when you write the mod 12 results, you can realign them so that they're mod 6. And I just didn't understand that until I finally did it. And I think it was Burton that helped me figure that out, because Burton did 2 over p and negative 2 over p and explained it. Explained it in terms of p is congruent to 1, 3, 5, and 7 mod 8. So once I saw that, I was like, oh, that's what I need to do. And I'll show it. I have it somewhere else. I'm just going through my notes, showing you fine folks on the interwebs, all the work that I did in quadratic reciprocity for this course. Yeah, it's been a lot of fun. You know, when you do, for example, 7 over p, yeah, here's 7 over p. You do p over 7 first, you lay them all out, and then you combine them with negative 1 to the p minus 1 over 2, which is either 1 mod 4 or 3 mod 4, and then you do all these Chinese remainder theorem solutions to find what the numbers are, and then you figure out what block they're in. So it's either that the product is 1, the product is negative 1, the product is negative 1, the product is 1. It helps to do a few examples so that you know which block you're in, because if you do an example for one of these 3 numbers, the other one's going to be just like it. It's going to give the same result. So that was pretty cool. That was pretty cool. You know, now, and again, just taking a course has made such a positive difference that now I know. Now I can honestly say, yeah, I understand those problems. I can do them. And I even did a few bigger ones. They just get messier, and it's not particularly enlightening. Then orders leading to primitive roots. Lots of primitive root problems. Finally, I understood. I watched a video on the internet once. I think it was the primitive roots of 56. I forget. And the person, Michael Penn, who makes great videos, I love his videos, just glossed over how he was able to hop on and figure out all the other primitive roots. And now I know the trick, of course, thanks to the course. The course did it. The course helped me. So there you have it. Took a practice exam. Here are the solutions. Did okay, but I learned through the practice exam that I wasn't as prepared for this exam as I was for the first exam. And now that I've gotten my grade back for both exams, I did a little better in the first exam, than I did in the second one. But both I did well enough to consider it a success, so I'm good. Then, of course, just as I did last time, start a new notebook. This is going to be a notebook where all the exam 3 notes are going to go on. Wrote out printed primes from Wikipedia, and then used them to do a bunch of Legendre symbols. Legendre symbols are tricky, my friends, tricky. You skip a -1 and you're done. And sometimes some of them will have you will have 3 or 4 flips, and you will have, in the end, if you put it all back together to the first one, you'll have 6 or 7 pluses and -1s that you multiplied. All you need is to miss 1 and you're done. And that's why here, when I go through these, there were so many that I got wrong. I got that one wrong, I got that one wrong. And these were the easy ones. Then I started upping the ante, going up, and then I still would get one wrong. Kept going and making them bigger, and every now and then I get another one wrong. And I can check the value in JupyterHub and Python. There is, I think it's in SymPy. I believe it's SymPy that has Legendre as a function that you can call, and it'll tell you whether your Legendre symbol is correct or not. Got that one wrong, but I got a bunch of them right, and I kept going up in value, just going back to this table and just finding, that one over that one, that one over that one. And sure enough, yeah, I got most of them right, but boy, they're tricky. Then this is how many minutes each problem took me. I did not study as hard for this exam, even though I did relatively about as well as the first one, which is great. I didn't have the time. I think I was missing like a good 2, 3, 4 more days to study for it, but we're going on vacation soon. So I was like, all right, I just got to do it. I don't want to spend my vacation thinking about an exam. That's just my own thing. And that's what happens when math is a hobby. You don't have to be as super gung-ho as you would be when you're on a campus and you're kind of like a captive audience. I'm not a captive audience. I got other things to do as well beyond what I'm doing here. But still, I've done well in the class and I feel very good about it. Did a bunch of problems, not as many as the first exam, but still a significant number. I think in all, I ended up doing 142 problems. And I think I did like 150 for the first one. So yeah, but here I'm gonna narrow down to, again, these are multiplicative function problems. -3/p. I finally understood it, and here it is. When you lay out 3/p, the possible values, and then you combine them with -1/p, you get these values. And then when you write them out in mod 12, okay, there are 1 mod 12, 7 mod 12 for the +1, and 5 mod 12, 11 mod 12 for the -1. When you lay these out and you start adding 12s, you end up getting mod 6. And I'm like, finally, I get it. You know, and then of course, because I had already done 5/p, 7/p, 11/p, I tried to do one of the big negatives. I forget which one. And it was like, all right, this is just soup, and there's no nice lining up the way it happens to a -3/p, where you can realign the mod 12s and turn them into mod 6s. It just doesn't happen. But the trick was to do -2/p from Burton. Once I learned how to do this in Burton, that was the trigger for this. So actually, I keep liking Burton more and more as I think a better book for an introductory course. Rosen will always be my best, but you know, Burton's doing pretty good, and it's helping me. So yeah, more problems. Every now and then I take a break and do a primitive root 37, just because I find it to be like really nice to just do calculations. I worked on Mobius inversion and I got some problems and I did them. I even did a more complicated one, but this has not come up in the exam. What came up was just regurgitate the formula and try to prove something. It's a combinatorial one that is 2 to the Wn, Wm being the distinct primes. I did okay, but I would have really liked this problem in the exam, something like this. This is kind of nice. Of course, I'm asking for an easier problem. I'm not sure that it's good if you want to get better at it. But yeah, so more Burton problems. Then yeah, 5/p, 7/p. I did them again, but this way as practice. Yeah, so here we go. I think, yeah, there you go. And these problems where you get a quadratic formula and you're supposed to figure out the solution, where you use d equals b squared minus 4ac and then 2ax plus b as the y. Yeah, I figured these out from a great example in Burton, but they did not come up in the exam. But I was ready to do them, even though they were not discussed in class. But then again, the derivative product was in the first problem in the exam, and that was never discussed in class. I felt that was a curveball. But you know, that's why you take a course, because somebody can send a curveball at you and you got to do something about it. And I did, and I think I did okay. So yeah, more Legendre symbols just for fun. They could have hit me with a much harder Legendre symbol than they did in the exam, and I still would have gotten it. I would have had a good chance of getting it right because I did so many of them, just for fun. Okay, and so yeah, more problems, more problems. Yeah, again, I started doing even more Legendre symbols. I'll do a couple of these in videos, and I did a couple more primitive roots of 19, which I believe was in the exam. I think that was the one that was covered in the exam. Anyways, and then some formula practice. I'm sorry, proofs practice. I keep calling it formula practice. And I've already started taking notes for the videos for Diophantine equations, which is the next chapter. So there you have it. Having fun. And number theory continues to rock my world.